Hey, what's up? This is Madan here, and I have brought another important topic from alcohol, phenol, and ether for all those who are in their 12th standard. This is really going to be a very important, topic. Why? Because this often comes out as a reasoning. If there is a question like, which out of alcohol, phenol, and water is a stronger chemical substance in terms of acid, then this might be very useful for you. And I must say this is like useful to almost everyone. I'll be comparing which one is a stronger acid and why. Let's start with the first one. The first one is about, I'm taking a chemical reaction. An alkoxide ion is produced by ionization of alcohol. So when it reacts with water, it gives a product alcohol. And apart from that, it also produces hydroxide ion. So what we see out here is that alcohol is receiving a proton from the water. So this is like your proton donor. This is your proton donor. H plus donor. And this is your proton acceptor. Right? So the chemical that is hydrogen acceptor is nothing but a base, or I should say, this is a Bronsted base. While this is a Bronsted acid. Right? You could also have written it this act as an acid, this act as a base, but I'm trying to make you go through some other topic as well. Now this one is a conjugate acid, and this one is your conjugate base. Now let me repeat what this is all about. If an alkoxide ion react with water, their water is a better proton donor when it comes to compare with alkoxide ion. So if water is a better proton donor as compared to alcohol, then this is a stronger acid than alcohol. So based on that, we can say water is a better proton donor as compared to alcohol. Therefore water is a stronger acid than alcohol. Right? Let me repeat back. If you react water with alcohol, what you see, there is a competitive environment, and during that competition, water is able to donate its proton first, right? And it donates its proton to the alkoxide ion. The alkoxide ion becomes alcohol again. Water itself becomes a hydroxide ion. So what we see, this is a proton donor while this is a proton acceptor. It means when you compare the acidity of both these two, water is coming out as a winner. That's why it is a stronger acid as compared to alcohol. Another reason is that it has a alkyl group. Alcohol has a alkyl group, and alkyl groups are electron donor. Remember, alkyl groups are electron donor, and a donor group always decreases the acidity. In alcohol, and when you compare phenol, what you see that the hybridization of the carbon is sp3, and there the hybridization of the carbon is, hybridization of the carbon is sp2. I hope you understand that. Now what is here, the S character is 25% only. The S character is 25%, but there S character is 33%. Let me repeat back in case you are not getting what this 25 is. See, it's 1:3 here. The ratio is 1:3, and there the ratio is 1:2. So 1:2 means, this is like 33% and this is like 67%. This is 25% and this is 75%. So because of that, S character is less here, S character is more here. Less the S character, electronegativity is less. Similarly, there electronegativity is more, right? So their electronegativity is less because there are less S character. Remember, S character is directly proportional to electronegativity. S character is directly proportional to electronegativity. So there is less electronegativity, there is more electronegativity. Now what happened? There is less ionization of proton. There is more ionization of proton. There is more ionization of proton, right? So let's come to the conclusion. Phenol can easily ionize and produce more hydrogen ion as compared to alcohol, and therefore what we can say, on this basis phenol is stronger acid than alcohol. That's it. So this is how we have come to the conclusion that if you compare alcohol with phenol, phenol is a stronger acid because it has higher degree of ionization of proton, right? Why it has higher degree of ionization of proton? Because it has higher S character, more electronegativity. This one has less, so there is less chances of hydrogen being produced. So I'm comparing water and phenol. I've already compared, alcohol with phenol, but this time we have to compare. See, I'll write here two different equations, and that will help you to understand what I'm trying to get it through. If water undergo ionization, this produces hydrogen ion and hydroxide ion. Similarly, if phenol undergo ionization, this produces a hydrogen ion and a phenoxide ion. Right? So this is what called phenoxide ion. In case you don't know, you have to be very, very, carefully learning all that. Phenoxide ion. And what this is your phenol. Now there is something very important. What happened? It undergo resonance. Right? So this is what changes are observed. Now there is single bond here. There is a lone pair with a negative charge. There you have double bond. There you have a double bond. There is again you have a double bond. And oxygen with a positive charge, with a neutral charge, and two pair of electrons. Now this will undergo, further movement, right? And what happened? You get your next structure, and that very next structure is This is something I've already done so many times, but I'm still doing that. So this is your double bond here. There is another double bond, oxygen, right? And there is a lone pair with a negative charge. So what happened this time? This go right here, and the double bond go right there, right? So what happened? So there you have a double bond. Now you have a lone pair, negative charge. There you have a double bond here. And there you have another double bond, a double bond with oxygen and two pair of lone pair. And what finally happened? This can happen like it go this way, the double bond will go this way. So this is the final change coming out to be. Right? There will be single bond, oxygen, and negative charge is restored. There is your double bond here, there is another double bond here, and there is another double bond. So what is happening here? Let me explain, because unless I explain it my way, it may not help you. When water generate the proton, right? When water generate the proton, it produces hydroxide ion, and which is not stabilized by any resonance. This doesn't have any resonance. But when phenol undergo protonation or hydrogen ion, when it produces hydrogen ion, the phenoxide ion can be stabilized by the resonance structure. So more than stability, higher will be acidity. Let me repeat. When water produces hydrogen ion, it remains with the hydroxide ion, and that hydroxide ion cannot be stabilized. But when phenol produces hydrogen ion, the phenoxide ion can be stabilized because it exhibits resonance effect. And because of this very important reason, phenol is a stronger acid than water. Alcohol is weaker acid than water, but water itself is weaker acid than phenol, right? Than phenol. Let's write. Because water is a better proton donor. Water is a better proton donor than alcohol. But water after producing hydrogen ion remain with OH negative, which cannot be stabilized, However, phenol after losing proton, remain with phenoxide ion, and it can be stabilized by resonance effect. So that's how I've come to the end of this topic. Let me repeat back. Water is a stronger acid than alcohol because water can easily donate proton as compared to alcohol. However, when you compare water with phenol has better stability because the phenoxide ion can go resonance effect. However, the hydroxide ion cannot. So in very simple, phenol is stronger as compared to water, and water is stronger as compared to alcohol. Now let's talk about the effect of substituents on the acidity of the phenol. Right? because there are two types of substituents. One is the one which exhibit plus R effect, and other one which exhibit minus R effect, right? So we need to consider both of them, and we need to find out the effect, if their effect on the acidity of the phenol. So the topic we have next is effect of substituent on the acidity of phenol. Acidity of phenol. Don't be too much critical about my handwriting. There's something I can't change, but I hope you understand exactly what I'm trying to write. People can have different ability and different I should say different ability. So I might have a different one. Let's find out. Suppose this is your alcohol, this is your phenol, alcoholic group on benzene, and then you have another compound here which is also benzene, and it has a alcoholic group. Now what you see that there is a alkyl group here, and let's take third example. It's going to be a short one just. So this is the third benzene. You have your phenol here, and then you have a nitro group. Now I'm about to compare which one is going to be more acidic, right? But before that, I want to tell you that there are two types of substituent. One that exhibit plus R effect. I hope you understand what plus R effect is. And other one that exhibit minus R effect. So a substituent which exhibit plus R effect, they decrease the acidity. They decrease the acidic strength. And a group which exhibit minus R effect, they increase the acidic strength. Right? So on this basis, let me explain you, because explaining is going to be really important. What we see that we have an alkyl group here. So alkyl group exhibit plus R effect. This exhibit plus R effect. So this actually increases the electron density towards the benzene. It increases the electron density towards benzene, and therefore the acidity decreases. So if there is an alkyl group which is electron donor and it is plus R effect exhibiting group, then it decreases the acidity. But on the other hand, if you have a nitro group which actually pull up the electron towards itself, so this exhibit minus R effect. Right? So if a minus R effect exhibiting group is there, this increases the acidity, but a plus R effect exhibiting group decreases the acidic level. So what that means, phenol is already acidic, however this will be least acidic and this will be the most acidic. So suppose I am naming this as 3 and this one as 2 and this one as 1, then order of acidity is going to be order of acidic strength is going to be you're going to have first it's 2 greater than 1 and finally greater than 3. Why? Because nitro is the electron pulling group. So when a group attached to the phenol, which is which exhibit minus R effect, it increases the acidity. However, a group like alkyl group, there are several other groups. You need to go back to your 11th class. from the organic chemistry, and there you will find out which group is plus R effect and which group has that minus R effect. But in short, I would say right here, a plus R effect exhibiting group decrease the acidity, but a minus R effect exhibiting group increase the acidity, and that's why I have made this sequence. Right? So with that, I must wind this video right here. I would say thanks for watching, and do let me know how this topic was. Was it really worthy? You really get help with something you were expecting, and say whatever you have to say. Right? Thanks for watching.